welcome back to lecture 4 of MCP. In the previous lecture we have studied about tools, prompt and resources. So in this video we will now going to integrate LLM and also going to understand server client communication with SSE, how the AI agent talk to model context protocol server. SSE is a server sent event. Basically this how the MCP server opens port for the AI agent to connect. So MCP server is our Python script which we wrote and gave it name as GitHub skill, and this is the endpoint on which it will open the SSE stream. And then the phase 2 is tool discovery. Now AI agent, what it will do, this is MCP client, it will going to discover the tools which we register with MCP. If we didn't start the MCP server, it never going to discover these tools. So first we need to start it, and I will make you show all the things while we are coding it. So now the phase 3 is JSON-RPC request. So it basically now the Groq client will send the request to MCP server, and it will use the function like the method, it will use the tool, and the name here is generate resume. Basically it is the name of the function which it is calling, and then the argument it is taking is the GitHub username, and then it send the request to the server's message endpoint. And the phase is what generate resume does. We wrote the function generate resume, and like what this function will going to do, I will also code this. Basically this is like whole combining the whole tools and generating the resume. So first the Groq client call this function and will use GitHub API, and then it will extract the profile, repository and language from it, and then we again going to give it to LLM, and then this will going to give us resume in bullets point. So this is the workflow. So this is the now summary of the MCP workflow. Like first the server exposes tool via SSE points, and then client connects and discover tools. As I already said, this client is your AI agent. If you don't register the tools, it will never going to find it, or either you never turn on the server, it will never going to discover these tools. So both the conditions must be satisfied for successful discovery of the tool for the client. Then third is client send JSON-RPC tool request, and then where it will going to get the data, and then server process and return the data, then AI agent create the final output. Here now we will going to code. Here we imported all the libraries which are needed, and then you have to to get the data from the GitHub. Like some repository are private, you can't access them. For that you have to make the client key and also add the secret key from the GitHub into your .env file, and from where you can authorize your GitHub, and then here you can use your Groq API key which you need to generate. And this is from the previous lecture. We have coded these things like the tools, all the tools, then tool 3. And then here what is new in this lecture or in this code, that we integrated all the tools. Rather than calling one by tool 1, we combined these tools in a single tool, which is we gave the name extract GitHub data, so that we can easily get all the data at a one place or from a single function, rather than calling multiple function. It is more easy and more comfortable while we are working. And this is the old code, the resources, like where the data should be available, and then the prompt, like how we want to generate our resume. And the new is here also, the data aggregation. Instead of only collecting repository name, we now collect the detailed repository information. This data will later be used by an LLM, so that we can better generate our resume. So instead of just collecting only just repository name or something, we are collecting the whole information about the repository. You can read this code line by line, like how this is working. And then here the detailed repository, and then we are running the for loop over the repository data. And then here we are collecting name, description, then how much star it got, the language, URL is for everything. So we are collecting more data so that we can use make our resume in a good way. You can read these things, like how we coded it. I have provided the link of my GitHub repo in the description. Then this is the Groq integration, what we have did in this Groq integration. Then our goal is to get the resume. So first we extract the data from GitHub, and then we provided it to Groq LLM, and then it will going to rank the repo according to the code we have provided it, or algorithm we wrote. And this is like how it will going to rank your repos. You can check it out on the GitHub repo. And like this is the job description, then repository name, everything. You can check it out, and you can also know about these parameter, like what is temperature, max tokens. You can also explore these things. Like the model we are using is LLM 3.370B versatile. And then this is the main tool, the GitHub resume generator. You can see it here, like how it is working. The first step is collect GitHub data. Here it is calling the function get GitHub raw, and we are also providing in GitHub username. And then Groq Client, we will going to provide it. For now we did it none, as we are taking this I took as an example just to show it locally. And then the step 3 is rank repositories. You can check all these things on the my GitHub repo, and then here we will going to start our the server. All the things like how it extracted all the information about the repositories, like the name and the description, language, star is fork. So here, like, now we started the MCP server. If you go here, you find nothing, but you have to press SSA at the endpoint. Now you can see that we have it started at the session ID on this, and then endpoint. At this endpoint, your AI agent will connect to your MCP server and will get to know available tools, and also going to send the request to it, like it again sending the a ping request, cause the this is called the heart rate of the server, so that it should stay active, so that if the client wants to get the data, it don't die, or like some channels or proxies might get closed if it don't run continuously.